Alright guys, so this is Systems 2 test review, part 2. So we're going to go and do the last page, page 21. So let's go ahead and get started. So for number 10 it says, what is the best estimate for the solution to the system represented in the graph? So remember that anytime that we have a system, our solution is going to be the point where those two lines meet. So in this case, those two lines aren't touching, but they will at some point. Remember that the arrows means that that line keeps going. Same thing, that arrow means that that line keeps going. So I should be able to extend these lines with my straight edge and then be able to tell where those two lines would match up. Okay, so that's what we're going to go ahead and do. I have a ruler. Obviously, if you don't have a ruler on you during the test, you could just use whatever straight edge you have, like your ID badge. So I extend that line, and then I extend this line. Alright, so of course it does say estimate. My line doesn't cross exactly, but it looks like it crosses at about this point right here. Or would it be, yeah, about that point right there. So I'm going to estimate that point is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 by 1, 2, 3, 4. So 9 by 9, 4 would be my estimate. Okay, for that solution. Number 11, what is the solution to the system of equations below? Again, I'm given a system. The easiest or more effective way to solve this is going to be with linear combination. Linear combination just basically means add my equations together. I don't have to modify or change my equations in any way because I already have a zero pair. That positive y, negative y, those two are going to cancel each other out. And then I can add the rest of these together. Okay. So we have negative 8x minus 5x is going to give me 3x. The equal signs come down, and then 20 minus 8 is going to give me 12. Divide both sides by 3. I get that x is equal to 4. Alright, from here I take the 4, I plug it back into one of my equations. I'm just going to go ahead and use the top one just for simplicity. Going to go ahead and plug in 4 in there. So the x goes away, 4 takes its place. Now I have 8 parentheses 4 minus y equals 20. And then 8 times 4 is going to give me 32. 32 minus y is equal to 20. And so now I can box this in and I can go in and solve. Minus 32 on both sides. Negative y comes down. Obviously I don't want negative y. I can put a 1, negative 1 in front of it. And that's what I divide both sides by, negative 1. I get that y is equal to 12. Alright, so my solution for this system is going to be 4, 12. Number 12. Olaf has 35 coins in dimes and quarters, totaling $4.25. Write a system of equation to represent the number of dimes and quarters that Olaf has. What does the solution mean? So we're going to write this out. So coins equations are always pretty simple. It's going to be part plus part equals whole, or in this case equals our total. I have two totals. I have a total of 35 coins, and I also have a total of $4.25. So I'm going to go ahead and start writing my equations. 35 coins and $4.25. Alright, the two parts that make up my coins are going to be dimes and quarters. I'm going to go ahead and use D for dimes, Q for quarters. So just simply dimes plus quarters equals my coins. For my money, I want to just basically attach each value to each one of these. Off to the side, I want to show you guys all of your values. So quarters are going to be 0.25. Dimes are going to be 0.10. Nickels are going to be 0.05. And then a penny would be 0.01. All right, and again, that's just they usually won't tell you how much the coin is worth. They kind of expect you guys to know that. So that's what you're going to need if they give you a coin problem. Okay, all I do is just attach the value to each coin. So with dimes, it's going to be 10 cents. So I can write this as 0.10D plus my quarters are going to be 0.25. So 0.25Q. Now that I have my equation, I can go in and solve. Let me grab a sheet of paper so I can solve it a little bit cleaner. All right, I'm going to go to rewrite my equation. So we have D plus Q equals 35, and then 0.10D plus 0.25Q equals 4.25. Sorry, my equal signs didn't actually line up. All right, so we basically want to create a zero pair. In front of this dime over here, I can go ahead and put a 1. In front of this quarter over here, I can put a 1. So really what I'm trying to do is I'm trying to get rid of either the positive 1Q or the positive 1D. It doesn't matter where I really start with. To get rid of that, we have to either make the 0.25 down here into a negative 1 so that those two cancel. Right? If I have 1Q and negative 1Q, those two things would cancel out. Or if I had 1D and negative 1D, those two things would cancel out. Right? So I'm trying to get my bottom equation to be negative 1Q or negative 1D. So with something like this, easiest way to think about it is first I want to get to 1. To get to 1, you basically just ask yourself how many quarters are in $1. So if I'm trying to get rid of quarters, I'm going to multiply this thing by 4. Or I could ask myself how many dimes are in $1. And if I want to cancel out dimes, I'm going to multiply this by 10 because there's 10 dimes in a dollar. I'm going to go ahead and do quarters. No, I'll go ahead and do dimes. Dimes, I'm going to multiply this by 10. I'm going to try to get these things to cancel out. So if I do 10 times 0.10, it's going to give me 1. But obviously I don't want 1 because 1D and 1D give me 2Ds. I want to have a negative 1. So instead I'm not going to multiply by 10, I'm going to multiply by negative 10. So negative 10 times 0.10 is going to give me what I want, which is the negative 1. Okay, so whenever I multiply this out, I need to multiply all of my equations by negative 10. Okay, top equation is going to stay. The bottom one is the one I change. I have negative 1D whenever I multiply that out. Negative 10 times 2.5 is going to give me negative 2.5Q. And then negative 10 times 4.25 is going to give me negative 2.5. Again, I usually tell my students, once you change one of your equations, go ahead and just kind of scratch it out. So I'm just going to put a few lines through this thing. And so that tells me that I'm adding the top and I'm adding the bottom. If you can, and if you like your work neat like I do, I'm just going to go ahead and take this equation, just rewrite it down here. And now we can go in and we can solve. So I know that these are going to be my zero pairs because I have negative 1D and positive 1D. Those are my zero pairs. Negative 2.5 plus 1 is going to be negative 1.5. And then negative 42.50 plus 30 is going to give me negative 12.5. Then I can divide that both sides by negative 1.5. and I get, is that right? Hold on, where did I make a mistake? Oh, here's where I made my mistake. Sorry, that should have been a 35, not a 30. So I get 7.5. So I get negative 7.5, and then I can divide that by negative 1.5. And I get 5. So what that means is he has 5 quarters, and now I need to figure out how many dimes he has. Well, this part's actually pretty easy. You can just kind of think about it. We knew that in total he had 35 coins. 5 of those coins are quarters. That means that out of the rest of the remaining ones, 30 of them have to be dimes. Your solution, depending on which variable you put in first. Our solution, for example, this might be something like 530. Or if we're going in alphabetical order, it would be 35. I'm going to go ahead and really quickly just put my variables up here. So quarters, dimes, just so that everybody knows I have 5 quarters, 3 dimes. And it even asks you, what does the solution mean? The solution means that we have 5 quarters and 30 dimes. Your solution tells you how many of each coin you have. That's exactly what your solution tells you when you're solving something like this. All right, number 13. Mary ordered lunch for herself and several coworkers on Monday and Tuesday. On Monday, she paid $7 for 5 sandwiches and 4 sodas. On Tuesday, she paid $6 for 4 of each. Find the price of a sandwich and the price of a soda. So again, I'm going to go and use my scratch paper. So she has 2 situations, and she has 2 totals that she pays. Again, we have part plus part equals total. First total that she paid was $7. $7, she bought 5 sandwiches and 4 sodas, so that's going to be 5. Let's see, what can I use for sandwiches? I'm going to let W be sandwiches and S be sodas. Right, so I can go ahead and write this as she bought 5 sandwiches, so 5 sandwiches plus 4 sodas gives her $7. And then on Tuesday she paid a total of $6, and she bought 4 of each. So 4 sandwiches and 4 sodas. All right, I need to solve my system. One thing that sticks out to me is that I have a positive 4s and a positive 4s that almost cancels out. They're not going to cancel out quite so nicely because they're both positive. 4 plus 4 is going to give me 8. But if I could somehow make one of these negative, then I would have positive 4, negative 4, and then they would cancel out. So what I'm going to do is I'm going to multiply, let's do the top equation this time. I'm going to multiply the top equation by negative 1 so that this positive 4 becomes a negative 4. Okay, and I really don't need this there. Alright, so I multiply everything by negative 1. So negative 1 times 5 is going to give me negative 5W. Negative 1 times negative 4 is going to give me negative 4S. And then negative 1 times 7 is going to give me negative 7. We add these together. 4 plus negative 5 is going to give me negative 1. These are the ones that create my 0 pairs. Those are the ones that go away. And then we have 6 plus negative 7 gives me negative 1. Okay? My solution to find out my W, I just simply divide everything by negative 1. I get that W is equal to something over itself is always going to be 1. So sandwiches cost $1. Now I have to go back in and figure out the price of sodas. I'm going to go ahead and use the bottom equation. Again, it doesn't matter which equation you choose. So we had 4 of each, so 4 sandwiches plus 4 sodas equals $6. I know that sandwiches are $1. So I can go ahead and plug in a 1 there. 4 times 1 is going to give me 4, so I can really just write that as 4 plus 4s equals 6. And then to solve for my missing variable, solve for s. I'm going to box that in, subtract 4. Six minus 4 is 2, then we divide everything by 4. 2 divided by 4 is going to be 0.5 or 50 cents. So find the price of a sandwich and the price of a soda. We can go ahead and write that. Sandwiches cost $1. Sodas cost 50 cents. All right, so that's my solution. Sandwiches are $1, sodas are 50 cents. All right, last one. And once again, we have another word problem. This time says Victor has twice as much money as Fred. Together they have $96. What system of equations, what system of equations that will, I think that's supposed to be write a system of equations that will determine the amount of money Victor V and Fred F each have. So all we're supposed to do is just write the system. We're not really supposed to solve. At no point on here does it tell me to solve. Just what system of equations would solve something like this. So we're supposed to just write this out. Okay, so Victor has twice as much money as Fred, and together they have $96. I'm going to go ahead and start with this statement right here. That together they have $96. Again, that's going to be one of our totals. So again, we have part plus part equals total. My total in this case is going to be 96. And the two people in this case are Victor V and Fred F. All right, so Fred plus Victor have $96. Okay? My other equation comes from 14, which says Victor has twice as much money as Fred. Now, twice in math means times 2. Victor has, in this case has, is giving us our equation that Victor has twice as much money as Fred. So if we take Fred's money and we double it, we are then equal to Victor. So again, one of our keywords here is has. Victor has twice as much money as Fred. So if we take Fred's money and we double it, we then come up with Victor's equation. So this one's going to be V equals 2F. So twice, if we take Fred's money, multiply by 2, we get Victor's. Again, this is not part of my equation. These are my two equations. That's my system. And with something like this, you have two options whenever it comes down to solving. Either you treat V like it's Y, and then we just solve for V over here. So I can show you guys that step more or less. Oops, 96. I would box in this V, pretending that's my Y, subtract F from both sides, pretending that's my X. Alright, so I'll get V equals 96F. I would then go into my calculator, type these in, again pretending that those are Y's, so really this would be Y equals 2X, and Y equals 96 minus X. And once I have those two equations, I can go in and solve and get my solution. Of course, it's a little tricky because you have to figure out which letter is which, but that's one way that you can solve. Or, of course, we can do substitution where we would say, hey, instead of that V, I'm going to put in 2F. And so we would have F plus 2F equals 96. And then we have that 3F equals 96. And then we would divide by 3. And we can figure out Fred's money, and then from there we can figure out Victor's money. So that's just how you would set something like this up and how you would solve. I hope this has been helpful. I hope that you guys are studying tonight, and I hope you do well on your test.